Okay, dear students, welcome to lecture number 2 on vapor power cycles. So, just we'll glance what we studied in the lecture number 1. So, in the lecture number 1, we started vapor power cycles. We discussed the definition, and we also discussed the difference between gas power cycle and vapor power cycles. So, these are 4 major components we discussed there. Here I have added 3, but one more is heat exchanger. There are 4 major components. So what is the major difference between these two is, so in the gas power cycles, so there is no change of phase of the working fluid, but in the vapor power cycles, so there is a change of phase of the working substance. So in one component, for example, in the boiler, the phase will convert from liquid, that is water, to steam, and in the condenser again steam will be converted back to water. So that is the one major difference between gas power cycles and vapor power cycles. Okay, and one more topic we discussed in the last class, that is last lecture. So vapor, that is formation of steam. So definition of boiler. Boiler is a closed metallic vessel in which the water will be converted into steam. And one more important point, we discussed the difference between vapor and steam. So vapor is nothing but there is some amount of water particles, water content will be there. So if you refer steam, it is 100% steam, there is no 0% of water. But in some books, both will represent the same. So one more procedure and concept we discussed. So we drawn formation of steam with TS diagram. So same TS diagram I will draw one more time here. So TS diagram, it is only for water. Okay, here we have considered the pure substance is water. So T temperature on the y-axis and H enthalpy on x-axis, enthalpy, and is also sometimes will be S entropy also. So this is called TS diagram or TH diagram. So this is temperature on y-axis. Okay, now dear students, what we discussed, just will glance for only 2 minutes. So here initially we have taken 0 degree Celsius water. So 0 degree Celsius water will be heated. So we will supply the heat. So 0 degree Celsius water will become 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, like that. So up to 100 degree Celsius will take. Here up to 100 degree Celsius. Here temperature of the water is now 100 degree Celsius. So at point number B, what is the condition of the working substance? Still it is in liquid form, that is water, H2O. Here is also H2O. So there is no change in the phase of the working substance. So amount of heat supplied during same phase or constant phase, but the temperature is increasing. So this is called sensible heat. So what type of heat we have supplied during A to B process? So sensible heat is supplied. Why it is sensible heat is supplied? Is nothing but, so there is no change in the phase of the substance. Phase remains constant, but temperature is changing, and this procedure, this step will takes place in the boiler, that is economizer part. And remember, now the temperature of the water is 100 degrees Celsius. Again I will supply heat, so temperature will be constant, that is 100 degrees Celsius, but water will be converted into steam at point number C. Here it is steam. So we are writing steam. So here there is a change of phase from water to steam. So when there is a change of phase of the working substance, so the heat what you are supplied is called latent heat. And this process B to C is taking place in evaporator. So this process is also called evaporation. In some of the interviews, in some gate questions, they may ask you, so in the evaporation what type of heat is supplied? That is nothing but latent heat is supplied in the evaporator. So, and one hint I will give, latent heat, LATNT, that thing stands for temperature is constant. And dear students, it is only for water. That is the reason is 100 degrees Celsius. If you take an ammonia pure substance, the latent evaporation temperature will be different. If you take nitrogen, evaporation temperature will be different. Here we are considering formation of steam. Steam is nothing but it is from water, H2O. Okay. Again, this 100 degrees Celsius, it is now pure steam. As if I use the word vapor, so here somewhere in between these two points B and C, if I take a point some here, one more point between B and C, here some percentage of water will be there, some percentage of steam. For example, here it is water, 100% water. If you take this point, 10% steam, 90% water. If you take here 20% steam, 80% water. So if you go towards and come back here, 50% water, 50% steam. So if you go towards point number C, so here 90% steam, 10% water, but exactly at point number C, it is 100% steam. So it is called dry point. So here it is wet point, it is dry point. But 100 degrees Celsius steam is not sufficient to generate electricity in the turbine. So in the usually practical applications, in the vapor power cycle, in the steam power plant, so 100 degrees Celsius steam will be converted into superheated state. Again I have to supply heat. So when you supply heat, so temperature is increases. So this is point number D I will take. Okay, and dear students, now here it is steam, but what is the phase at point number D? Again it is steam. Here the phase is remains constant. So when the working substance phase is constant, so what type of heat you are supplied? Latent heat or sensible heat? Yes, sensible heat. If you supply latent heat, phase will change. So here again, what type of heat it is? Sensible heat. So this process will take inside superheater. And dear students, one point you remember, so the boiler consists of three major parts: economizer, evaporator, superheater. In the economizer, sensible heat is added. In the evaporator, latent heat is added. In the superheater, again sensible heat is added. So in the superheater, temperature changes. Evaporator, constant temperature, but phase changes. I will write here phase change, but temperature is constant. Here phase is constant. Phase constant means it remains same phase. There is no change of phase from liquid or to vapor. And dear student, this entire three process, economizer, evaporator process, superheater, it is at constant pressure. So in the basic level, in the PUC, in the SSLC, what you studied, so 100 degrees Celsius is the boiling point of water. At what pressure? It is at 1 atmospheric pressure. 1 atmospheric pressure. So this curve is 1 atmospheric pressure. If you take for 2 atmospheric pressure, whether the temperature increases or decreases, obviously the temperature increases. So instead of showing 100 degrees Celsius, so it will be above. So I will draw one more line. So this is 1 latent heat, again second, this is at 2 atmospheric pressure, again if you doing experiment for 3 atmospheric pressure, again economizer, latent heat and superheat. this is at 3 atmospheric pressure. And similarly for 4, 5, 6, 10, 20, 100, 200 degree, 200 atmospheric pressure, just you observe carefully as the pressure increases. Here you increase the pressure. Here it is 1 atmosphere, 2, 3, 4, 10, 20. As the pressure in the boiler increases, the latent heat length is goes on decreasing. So here you can see that here it is wet point, that is water. Here is also water. Here is also water. Again, if you are doing for 10 atmospheric pressure, 100 atmosphere, 10, 20, 1 atmospheric pressure, nothing but 1 bar, right? 1 bar. Here it is 2 bar. 2 bar. Here it is 3 bar, 4 bar, 10, 20, 30, 40, 50, 100. So just you, as the pressure is increasing, the latent heat length is goes on decreasing. Now it will become a peak point here. Okay, now at this peak point. Now I will join all these wet points. Here is wet, water, here will be water. And dear students, this is at 2 bar. If you not consider here, this diagram will be for 1 bar, this diagram is for 2 bar, and this curve is for 3 bar. Similarly goes on. So now I will join all these points. So which points I am joining now? I am joining all water points, that is wet points. So now this line, what you call it is, it is a saturated liquid line. Don't call it as water line, because if the working fluid is water, then it's correct. But in some cases, if you are doing an experiment for ammonia, you cannot say saturated ammonia line. So saturated liquid line in general, it is called liquid line. So at the same time, in the latent heat on the right side, here the point number C, it is steam. Here it will be at steam. So now I am joining all these points through this line. So here it is steam. Steam is nothing but what? Dry. Here is also dry. There is no water content. Here is also dry. I am joining all dry or saturated points. So this line is called saturated vapor line or dry saturated line. Why I am using the word dry is, here there is no water contained in the steam. Completely it is steam. And here it will, between these 2 points, it is a mixture of both liquid and vapor. Here is also liquid and vapor. We don't know the percentage of how much percentage of liquid, how much percentage of vapor. But when you come back to at point number B, what is how much percentage of vapor? Here 0% vapor, 100% water. But at point number C, here it is 0% water but 100% steam. I will write here 0% water and here 100% steam. So why I am using these 2 terms, it will become easy for solving the problems here. Okay, so this is called TS diagram or TH diagram. H or S, temperature versus enthalpy. So this is saturated liquid line and saturated vapor line. So in between these 2 lines, latent heat. On the right hand side it is superheated heat, on the left hand side it is sensible heat. So this is economizer, here it is evaporator, and here it is superheater. So this curve is at constant pressure. It may be 1 bar, it may be 2 bar, it may be 3 bar. And dear students, now at this point, if I ask you a question, what is the temperature of saturated liquid line at this point? Just an example. So what is the temperature at this point for saturated liquid line? So we don't know. At the same time, if I ask you a question in other way, what is the temperature of dry saturated line at this point? But this point is same for saturated liquid line as well as this point is same for saturated vapor line. So point in which both saturated liquid line and saturated vapor line are meets together, joined together. So that point is called critical point. That point is called critical point. Understood now? So critical point, saturated liquid line, saturated vapor line. This is latent heat, this is sensible heat, again this is superheated heat. So this is an explanation about formation of steam. Okay, so this formation of steam will takes place in a device, or not, it is not a device, it is a closed metallic vessel. Okay, so that vessel is called boiler. So now we'll go to the next topic, that is vapor power cycles. So it is also called steam power plant and it is also called steam power cycles. And these ones, these vapor cycles, steam power plant and steam power cycles are works or operates on the principle of Rankine cycle. Rankine cycle. So very important question for exam point of view. So in the exam they may ask you derive an expression for efficiency of Rankine cycle with TS diagram, or explain briefly the working of vapor power cycles. This question has asked many times in the VTU question papers. Already VTU question papers are circulated to you, so you can cross check. Okay, this is for 10 marks questions, Rankine cycle. Now we will discuss today the working of Rankine cycle as well as the derivation of efficiency of Rankine cycle. So Rankine cycle consists of 4 major components. First point, it consists of 4 major components. What are those 4 major components? First one is boiler, second one turbine, and third one is condenser, and fourth one is pump. Okay, so now, and dear students, observe carefully here vapor power cycles we are discussing. Now if I ask you a question, how will generate vapor? So boiler. So we'll take boiler. So first major components will come into the picture is boiler. So I will take one boiler. Here is a boiler, B-O-I-L-E-R, boiler. So boiler is available with us. Now it is available. Now how will convert water into steam? I have to supply water. Here water is supplied. Now water is available inside the boiler now. So if you supply water to the boiler, automatically will not convert water into steam. So what you have to supply? We have to supply heat. Very good. You have to supply heat. So heat we are supplying. Heat. Q. Heat will be represented by letter Q in thermodynamics. So QS stands for heat supplied. Now as I told you, this diagram, the formation of steam. So here 0 degree Celsius water I am supplying, 10 degree, 20 degree, 30 degree, 40 it will become 100 degree. So what type of heat you have supplied here? Sensible heat. So 0 degree, in the industry they will not supply 0 degree Celsius, obviously it is 40 degree Celsius or 50 degree or atmospheric temperature 25 degree Celsius water. So boiler will generate water to steam. Now here the steam is coming outside. Now I will draw one steam diagram. Here it is steam. Steam which is coming outside. And dear students, if I ask you what type of steam is coming outside the boiler, so 1, 2, these 3 are components of the boiler. So point number D is coming outside the boiler. So what type of steam it is? Only dry steam or superheated steam? Yes, it is superheated steam. So superheated steam is coming outside the boiler. Superheated steam. This superheated steam is supplied to a turbine. So it is a steam turbine. In the industry, the steam turbine will be insulated. The steam turbine will be insulated. The reason is the heat should not go outside. So Q is equal to 0. The heat should not go outside. Q is equal to 0. So what type of process? In the process in which heat exchange, if it is equal to 0, what type of process? What is the name of the process? It is called adiabatic process. Very good, correct. Adiabatic process. So this turbine is coupled to a generator. Coupled to generator. Here, generator. So after expansion, this superheated steam undergoes expansion. We will discuss right later. So the steam which is coming outside the turbine, that is steam, so will be supplied to condenser. So in the condenser, here it is hot steam. Obviously hot steam is going inside. So condenser is a device which converts the steam to liquid, that is water. Just you observe here water is converted into steam, heat is added. But here steam is converted into water, heat will be added or heat will be rejected. So heat is rejected, that is QR. Heat is rejected from the condenser. So in the condenser we will supply cold water. Here we will supply cold water. So this cold water enters inside the condenser, and here hot steam. This hot steam and cold water, there is a physical contact between these two, indirect contact. So then heat exchange takes place. So the cold water absorbs heat from all the steam. It will go outside. It will become hot water. And this hot water will be supplied to cooling tower. Here. Okay, direction has become reverse. Here I will take cold water. Here cold water is supplied to the condenser. Cold water absorbs all the heat. It will become hot water. This hot water will be sent to the cooling tower. They will spray here like that, just like a sprinkling, just here showering. So this hot water will come downward due to gravity. So when it is coming down, this hot water will be converted into cold water. So cold water will be separated. So the height of this cooling tower will be too much height. So such type of cooling towers you might have seen in Raichur thermal power plant and in the Ballari side. Okay. So this water will be pumped to boiler with the help of pump. So 4 major components. One is boiler, turbine, condenser, and here it is pump. Okay. So Rankine cycle consists of 4 major components: boiler, turbine, condenser, and pump. In between these two there will be many components, but here it is only 4 major components. So this completes Rankine cycle. This is construction. Okay. Now we'll take point number 1, point number 2, point number 3. So for example, here I will start this. I will take point number 1, and here point number 2. Here there is some reservoir. Assume that initially here there is some reservoir, tank. See, here water absorbed from the pump is supplied to the boiler. So 1 to 2 process process 1 to 2. So what type of process it is? Here work is done on the pump or work is done by the pump? Oh, correct. Work is done on the pump. We are supplying electrical energy, that is called work input. But here in the turbine you are generating electrical energy, that is work. So work is done by the turbine, work is output. So it is called WT. WT is outside. WP I will use the word WP because work done on the pump. So work done by the turbine. Okay. So process 1 to 2 is what type of process it is? Reversible adiabatic compression process. Reversible adiabatic compression process. So it is also called as, what is reversible adiabatic compression? Another name for is constant isentropic compression process. Isentropic process. Now 1 to 2. Now 2 to 3. Here it is point number 3. So during 2 to 3 heat is added. So process 2 to 3, it is a what type of heat is added? It is a constant pressure or constant temperature. Just look at into the formation of steam diagram. So from here to here it is a boiler, that is very clear. We told you from here to here it is boiler. So entire process is at which constant pressure process. So constant pressure process, or it is also heat addition process. In exam how you have to write? Process 2 to 3, it is a constant pressure heat addition process. Constant pressure heat addition process. So process, now you are at this point. So 3 to 4 exactly opposite to the pump. Here pump is absorbing work, turbine is work producing work. So it is a turbine is a work producing device. Understood? So here it is compression, obviously it will be expansion. So this superheated steam undergoes expansion process. So what type of expansion it is? Again adiabatic expansion process. So expansion process is also called isentropic process. What type of it is? Reversible adiabatic expansion process. 1 2 3. So one more is fourth process. So I will take page number 4 here. So I will refer to this diagram, it will become easy for you to understand. So 4 to 1, whether this heat is added or heat is rejected or compression or expansion. Between 4 to 1, you guess it now. So 4 to 1 heat is rejected. So I will write here process 4 to 1. So process 4 to 1 heat is rejected. And now question arises in our mind, what type of heat is rejected, which process it is, whether it is constant pressure, constant volume or constant temperature. Understood? Now dear students, in the boiler we told you there are 3 parts. One is economizer, evaporator and superheater. This is the diagram. So economizer, evaporator, superheater. Out of these 3 parts, in which part there is a change in phase? That is in the evaporation part. That is evaporator. So much heat is required for converting water to steam. Understood? So compared to 1, 2, 3, the major part is this much. This one is the major part. So what type of heat you have supplied? If as latent heat is supplied. Latent heat is supplied. So when you have supplied latent heat to a substance, what type of heat is rejected? Obviously it is latent heat. Have you got my point? So in interviews or in the Viva questions or in the GATE exam, they may ask you such questions. So what type of heat is added in the boiler? So it is a latent heat. So what type of heat is rejected in the condenser? It is a latent heat. And one hint I will give how to remember this. So there are two types of heat you have studied. One is sensible heat, another one is latent heat. So when you call it sensible heat, sensible is nothing but phase remains same, temperature changes. But latent heat, temperature is constant but phase changes. So that is called, here it is water and here it is steam. The phase is changing or it is same? Obviously phase is changing. So when there is a change in phase, what type of heat you should supply? So latent heat. Here is also, here it is steam. Steam is becoming water. There is a change of phase. So when there is a change in phase of the working substance, so what type of heat will be rejected? Obviously QR. So I will write here for you understand. For you people understand. Note. I will write a note. Note here water. Here water H2O. Water is converted into steam. So latent heat is added. Latent heat is added. But when you are converting steam to steam, converted into water, so latent heat will be rejected. Understood? Latent heat is rejected. QR. Here Q, yes. So you remember this point. It is very important for solving the problems as well, and such type of questions may be asked you in the interviews. Okay. So now come back to the Rankine cycle. Okay. So first point, it consists of four major components. So the boiler, turbine, condenser, and the pump. So in four major components are there, four processes will be there. So process 1 to 2, and which component? Process 1 to 2 is taking place which component? Process 1 to 2 is in pump. Process 2 to 3 is in boiler. 3 to 4 in turbine. And 4 to 1 in condenser. So now we'll go once again, I will explain continuously. So 1 to 2, process 1 to 2 is a reversible adiabatic compression process. It is also called isentropic. So here the water is pumped from a reservoir to the boiler. Okay. So here pressure is increases from P1 to P2. Obviously pump, if you are using pump, pressure increases P1 to P2. Okay. Now the point number 2 is water. Water is supplied to the boiler. Here evaporator will be there and superheater will be there. So at the end of the boiler we are getting superheated steam. Here pressure is P2, temperature is T2, and here pressure is P1, temperature is T1. So this high pressure, because this is low pressure. So pressure is increasing P1 to P2. So obviously it is high pressure. So high pressure temperature liquid is supplied to the boiler. Here latent heat is added. So due to supply of heat, the pressure remains constant here because it is constant pressure process. We have written here 2 to 3 constant pressure. Here it is high pressure is nothing but here obviously it is high pressure only. Pressure is same, no? If it is 100 bar, here is also 100 bar, 50 bar, 50 bar, pressure will be remain same. Here is high pressure is going inside the boiler, obviously at the outside high pressure, but temperature is low temperature is going inside the boiler. Due to supply of heat, the temperature is increases, so it is high pressure, high temperature, high pressure, high temperature, superheated steam. Once again I will write for you people: high pressure, high temperature, high pressure, high temperature, superheated steam is supplied to the turbine. And here shown what type of turbine it is. It is a gas turbine or water turbine or steam turbine. Obviously it is steam turbine because working fluid is steam. If you are supplying water, it will become water turbine. In the previous chapter we have used gas turbine because working fluid was gas. Here is steam turbine. And in the industry, the steam turbine is insulated. Entire turbine will be insulated because to prevent the transfer of heat. Why? Because if you not insulated, if you not insulated the turbine, all heat will go outside, so mechanical work output will be less. Understood? So it is insulated. So high pressure, high temperature, superheated steam expands in the turbine. Expansion takes place. So due to expansion, the steam which is coming outside, it is at low pressure. High pressure will become low pressure and low temperature. Low temperature. So now I will give the notification. What is the pressure at point number 3? P3. What is the temperature at point number 3? T3. What is the pressure at point number 4? P4. What is the temperature at point number 4? T4. So this is low pressure, low temperature. So low pressure steam, low temperature steam will supply to the condenser. So condenser is also at constant pressure. Here is constant pressure, this is also constant pressure. Exactly opposite. Here heat is rejected, I have written. Now I will write. So what type of heat is rejected? So heat is rejected at constant pressure. So this is brief description about the Rankine cycle. Now all these four processes you have to draw on TS diagram. That is very important for exam point of view. So without TS diagram you will not get the marks. Okay. Now page number 4, I will draw the TS diagram. TS diagram for which cycle it is? TS diagram for Rankine cycle. Okay. TS, temperature on y-axis, entropy on x-axis. And dear student, this is also called TH. Okay. So when you are drawing TS diagram, first you represent saturated liquid line and saturated vapor line. That is what we discussed just before 10 minutes. First you have to draw saturated liquid line, saturated vapor line. So first I will draw saturated liquid line, saturated vapor line. So the point in which both these two lines are meeting, what is the name of that point is called critical point. ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ಅರ್ಥ ಆಗುತ್ತೆ. Critical point. Okay. So what is the name of this line? Saturated vapor line. This is saturated liquid line. Saturated liquid line. Same these questions, these topics you have studied in basic thermodynamics in the last semester. Basic thermodynamics ಮತ್ತೆ ನೀವು ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ, ಪಾಠ ಮಾಡಿದ್ದೀರಾ, ಕ್ಲಿಯರ್ ಆಗಿದ್ದೀರಾ, ಪಾಸ್ ಆಗಿದ್ದೀರಾ. ಓಕೆ. ಸೊ ಈಗ all these four processes we have to represent in the TS diagram. So now I will open this diagram what we discussed just now. So I will start from 1 to 2. So 1 to 2 is which process? Isentropic process. Isentropic process, which property remains constant? Pressure will remain constant, or volume will be constant, or temperature will be constant, or entropy will be constant. Right? Entropy. So entropy will be constant. So S1 is equal to S2. Okay, but pressure is increasing P1 to P2. At the same time temperature is also increasing. So now I will draw one vertical line in the TS diagram. Simple. So this is 1 to exactly straight line 1 to 2 because it is entropy is constant. So S1 is equal to S2. Okay, so you put effort, you will understand better, don't worry. So S1 is equal to S2. Next, so 2 to 3, what type of heat is supplied? Constant pressure heat addition process. So constant pressure heat addition process. Now, so in the boiler, how the first time formation takes place? Three process: evaporate, economizer, latent heat, that is evaporator, and superheater. That diagram I will draw here. Give me 2 minutes. Yeah, here. So same from this point to this point, it is boiler. So if you are not considering point number D, if you are ending the curve only at point number C, it will become only dry steam. Okay, if you are ending this curve here, only it is dry steam, but you are extending, it is superheated steam. So now I will draw the TS diagram. So what is this line? It is evaporator line, and here it is latent heat line. Now if you stop here, it is dry steam, but I will make superheated steam, superheated. Okay, so this superheated steam, this is dry steam, here it is water. Okay, now this I will draw. Expansion takes place in the turbine. So I will use different color chalk piece, so it will become easy for you to understand. So on third process, what is the name of the third process? Dear students, what is the name of the third process? That is 3 to 4. It is reversible adiabatic expansion. Expansion in the turbine. What type of expansion it is? Isentropic expansion. So isentropic nothing but entropy remains constant. So S3 is equal to S4. S3 is equal to S4. That is the reason I have drawn a vertical line. This is point number 3. This is point number 4. S3 is equal to S4. Now 4 to 1 is which process? 4 to 1 is constant pressure process. One doubt is there in your mind. I will ask you that question only. All of you must answer. So that question you ask when I am conducting online class. Okay. Okay. Now 1 to 2 is work done on the pump, WP. Okay. So 2 to 3 is heat addition. 2 to 3 is entirely heat addition process, not only this. From point number 2 to point number 3, it is heat supplied, QS. So 3 to 4 expansion work done by the turbine, and 4 to 1 heat is rejected. Okay, now in the thermodynamics or in the first chapter, so what we discuss is constant pressure process will be represented by curved line in the TS diagram. I will repeat my words again. In the TS diagram, here you look at it here. In the TS diagram, constant temperature will be represented by horizontal line, and entropy will be represented by vertical line. All remaining process represented by curved line. Correct. Constant temperature will be represented by horizontal line, and constant entropy will be represented by vertical line. Other than these two, all remaining process will be represented by curved line. Now here it is TS diagram, here is also TS diagram, but 2 to 3 is constant pressure, so 2 to 3 process should be drawn curved line, but here we have shown horizontal line. These two are okay, almost this is also curved, this is also curved, but this latent heat line I have represented by constant temperature. Why? The question is why? Okay, one more question I will ask you. 4 to 1, okay, 4 to 1 in the diagram. 4 to 1 is which process? Constant pressure heat is rejected, so constant pressure will be represented by curved line, but I have shown in the horizontal line. Again, why? So these two answers for these two questions will be discussed in the online class, that is online Zoom class. I will be planning for conducting online Zoom class, so you must be answered, otherwise ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಗೊತ್ತಾಗಲಿ, ಗೊತ್ತಿಲ್ಲ ಅಂದರೆ ಮರ್ತು ಬಿಡಿ ಅಷ್ಟೇ, ಸಿಂಪಲ್. ಸೊ ಸ್ಟೆಪ್ ಆಫ್ ಕ್ವಶನ್ಸ್ ವಿಲ್ ಬಿ ಆಸ್ಕ್ ಇನ್ ದ ಗೇಟ್ ಎಕ್ಸಾಮ್, ಕೇಳ್ತಾರೆ, ವೈವದಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಓಕೆ, ಯಾಕೆ ಕಾನ್ಸ್ಟೆಂಟು ಹಾಕಿದ್ರು ಅಂತ ಕೇಳಬೇಕು. ಈಗ ನೋಡಿ, ಸೊ ದಿಸ್ ಈಸ್ ದ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಆಫ್ Rankine cycle on TS diagram. I will write here Rankine cycle. Okay, so ಈಗ ಇದು ಓನ್ಲಿ ಪ್ರಿಸ್ಕ್ರಿಪ್ಷನ್ ಆಯಿತು. explain about Rankine cycle ಅಂದರೆ ಇಷ್ಟು ಬರೀತೀರಾ. In some question papers what they asked is derive an expression for efficiency ಅಂತ ಕೇಳಿದ್ದಾರೆ. How the question is asked for 10 marks, derive an expression for efficiency of a turbine. So ಈಗ efficiency of turbine ಅನ್ನು derive ಮಾಡೋಣ. ಸೊ ಫಸ್ಟ್ 1 to 2ಗೆ ಈ ಡೆರಿವೇಷನ್ ಮಾಡಬೇಕು ಅಂದರೆ, ವಾಟ್ ಈಸ್ ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ಎನಿ ಸೈಕಲ್? ಔಟ್ಪುಟ್ divided by input. Okay, in this cycle, at the same time ನಾನು ಇದು ಇಟ್ಟಿರ್ತೀನಿ, it will become easy for you to understand ಅಲ್ವಾ. So in this cycle, which is the output is nothing but coming outside the cycle ಅನ್ಕೊಳ್ಳೋಣ. So here is one output, here is one output, both are coming outside the cycle, and these two are inputs. Okay, but here Rankine cycle, it is for power generating. You have to concentrate only on work W. So output is nothing but work output. Input, here pump is also input and heat is also input, but the major one is heat is input, that is heat supplied. Okay, in the last semester one student has asked a question, very good question he has asked. Sir, here it is pump, work is supplied, here work is output, work is done by the turbine, but in the TS diagram 1 to 2 is represented with small length of line, 3 to 4 is represented with the long length of line. Yake? Why? Is compared to turbine, the pump work supplied is too less. Here if I supplied 10 joule of energy, but here I am getting 100 joule of energy. That is the reason it is a benefit for the cycle, otherwise there is no benefit. For example, if you are spending 100 rupees here and you are getting only 20 rupees as a profit, what is the use of running the Vapour cycle? No, right? So all steam power plants in the world are works on the principle of Rankine cycle. So every day what energy, electricity we are getting through Vapour power cycles. Steam power plant andru onde, Vapour power cycle andru onde, Rankine cycle andru ondene. Okay, so this is TS diagram. Efficiency of first you have to calculate work and heat supply, but some books they will write net work done. I told you that work done by the turbine is less compared to pump, but some books some scientists, some researchers, they will not neglect the work supplied to the pump. So they will take net work done. So work done by the turbine minus work done on the pump. That will be the net work done, obviously. So heat supplied, that is QS. QS will be heat supplied. This is efficiency equation. And dear students, these two questions I have asked you. You refer any standard textbooks or internet facility and find out the answer for this. And one more question is added to these questions. One question is added to these questions. So what is that question? Here, this question is asked in interview for me. Okay, here it is steam. Understand the question carefully. Here it is steam, and outlet of the turbine, you are getting steam. Here only difference is, here is high pressure, high temperature, superheated steam, but here low pressure, low temperature steam. Understood? So the steam which is coming outside the turbine, it is not dry steam. Okay, so once it undergoes expansion process, some amount of steam will be condensed to water. Some amount, 10% of steam will be condensed to water. That is the reason in the TS diagram we have the point number 4 is inside the cycle, inside this line. Understood? If this point number 4 is on this line, then assume that it is dry. Point number 4 is 100% steam, but point number 4 will not be 100% steam. It is having some amount of water. So don't draw 3 to 4 inclined line. Only some amount of water, some amount of steam will be converted into water. And don't represent point number 4 on line also. It is not possible practically, but in some problems for cases they may give, but in the real applications, in the industry, in the plant, it will not work out. So point number 4 will be inside the saturated vapor line, or it should be nearer to. Don't take 3 to 4 inclined line. So for 4, 50% water will be there, 50% vapor will be there. That will sends to boiler. ಆ ಥರ ಇರೋದಿಲ್ಲ ಅದು. ಓಕೆನಾ? ಸೊ ಪಾಯಿಂಟ್ ನಂಬರ್ 4 ಇಲ್ಲಿದೆ ನೋಡಿ. ಅದಕ್ಕೋಸ್ಕರ ಇದು ಸ್ಟೀಮ್ ಇದ್ರೂ ದಿಸ್ ಇಸ್ ಎ ಲೋ ಪ್ರೆಷರ್, ಲೋ ಟೆಂಪ್ರೇಚರ್ ಸ್ಟೀಮ್. ಇಲ್ಲಿ ಸೊ ಲಿಟಲ್ ಬಿಟ್ ಸಮ್ ಪರ್ಸೆಂಟೇಜ್ ಆಫ್ ವಾಟರ್ ವಿಲ್ ಬಿ ದೇರ್. ಸೊ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್ ವಿಲ್ ಬಿ ಕಂಡೆನ್ಸ್ಡ್. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸ್ಟೀಮನ್ನು ಸ್ವಲ್ಪ ಕಂಡೆನ್ಸ್ ಆಗಿ ವಾಟರ್ ಆಗುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಈಗ ಏನು ಕ್ವಶನ್ನು ಅಂತಂದರೆ, ಇಲ್ಲಿ ಸ್ಟೀಮ್ ಇದೆ, ಸೂಪರ್ ಹೀಟೆಡ್ ಸ್ಟೀಮ್ ಇದೆ, ಇಲ್ಲೂ ಸ್ಟೀಮ್ ಬಂದಿದೆ. ನಾನು ಈ ಸ್ಟೀಮನ್ನ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಸಪ್ಲೈಯಿಂಗ್ ದಿಸ್ ಸ್ಟೀಮ್ ಟು ದ ಕಂಡೆನ್ಸರ್, ಡೈರೆಕ್ಟ್ಲಿ ಐ ವಿಲ್ ಸಪ್ಲೈ ದಿಸ್ ಸ್ಟೀಮ್ ಟು ಬಾಯ್ಲರ್. ಸುಮ್ಮನೆ ಡಯಾಗ್ರಾಮ್ ಹಾಕ್ತೀನಿ ನೋಡಿ, ಅರ್ಥ ಆಗಂಗೆ. ಓಕೆ, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಂಗೆ ಐ ವಿಲ್ ಡ್ರಾ ಒನ್ ಸಿಂಪಲ್ ಡಯಾಗ್ರಾಮ್. ದಿಸ್ ಇಸ್ ಓನ್ಲಿ ಫಾರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ಎಕ್ಸಾಮಲ್ಲಿ ಕೇಳ್ಬೋದು, ಕೇಳದೇ ಇರ್ಬೋದು, ಬಟ್ ಫಾರ್ ನಾಲೆಜ್ ಪರ್ಪಸಾಗಿ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಸೊ ನೋಟ್ ಏನಂತ ಕೇಳ್ತಿದ್ದೆ ನಾನು. ಸೊ ದಿಸ್ ಈಸ್ ಬಾಯ್ಲರ್, ದಿಸ್ ಈಸ್ ಟರ್ಬೈನ್. ಥಿಂಕ್ ಮಾಡೋ. ದಿಸ್ ಈಸ್ ಕಂಡೆನ್ಸರ್ ಸಿ ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ಪಂಪ್. ಹಿಯರ್ ಇಟ್ ಈಸ್ ಸೂಪರ್ ಹೀಟೆಡ್ ಸ್ಟೀಮ್. ನಿಮ್ಗೆ ಆನ್ಸರ್ ಗೊತ್ತಿದೆ, ಬಿಕಾಸ್ ಒನ್ಸ್ ವೆನ್ ಐ ಡಿಸ್ಕಸಿಂಗ್ ಗ್ಯಾಸ್ ಪವರ್ ಸೈಕಲ್ ಇದನ್ನು ನಿಮಗೆ ಕೇಳಿದ್ದೆ ನಾನು ಕ್ವಶನ್ ಕ್ಲಾಸಲ್ಲಿ. ನೀವು ಆನ್ಸರ್ ಕೆಲವೊಬ್ಬರು ಮಾಡಿದ್ದೀರಾ, 100 rupees ಅಂತ ಹೇಳಿದೆ, ಕೆಲವೊಬ್ಬರು ಹೇಳಿದ್ದೀರಾ, ಕೆಲವೊಬ್ಬರು ಹೇಳಿಲ್ಲ. QR, QS, this is work done by the turbine, work done on the pump, this is Rankine cycle. So what my question is, here you are getting low pressure steam, here it is high pressure steam. So this low pressure steam, instead of supplying to the condenser, I will supply directly low pressure steam to the boiler. So low pressure steam, here it is going inside the boiler and I will supply heat. So low pressure will become high pressure. ಈ ಎರಡು ಕಾಂಪೊನೆಂಟನ್ನು ತೆಗೆದಿದ್ದೀನಿ. I will eliminate these two components. Is it possible? My question is it possible? So it will not possible. ಆಗೋದಿಲ್ಲ. Why? Question. One more type. There are two answers you can give for this question. Okay, there are two ways ಅಂತ ನೀವು ಆನ್ಸರ್ ಮಾಡಬಹುದು. ಇದು ಒಂದು ನೆನಪಿಟ್ಕೊಂಡು ಯು ಸರ್ಚ್ ಇಂಟರ್ನೆಟ್ ಫೆಸಿಲಿಟಿ ಇಂಟರ್ನೆಟ್ ನೋಡಿಕೊಂಡು ನನಗೆ ಆನ್ಸರ್ ಹೇಳಿ ಆನ್ಲೈನ್ ಕ್ಲಾಸಲ್ಲಿ. ದೇರ್ ಆರ್ 2 ಕ್ವಶನ್ಸ್ ಐ ಆಸ್ಕ್ ಯು. ಓಕೆ, 2 ಕ್ವಶನನ್ನು ಹೇಳಿ. ನಾವು derivation part, we will go to derivation part. Okay, so Wt minus Wp divided by Qs. So now I will calculate Wt equation, I will calculate for Wp equation, and we will write the equation for Qs. Once you substitute all these parameters, we will calculate the efficiency of the cycle. What is the name of this cycle? Rankine cycle. Okay, Rankine cycle. Now, so I will calculate Wp. So Wp is, I will take new page. So first we will calculate Wp. Wp is equals to isentropic compression. So when you are writing Wp 1 to 2 process, pressure is increasing from P1 to P2. It is low pressure, it will be high pressure. So what is the equation for W? W is equal to integral of, nodi. So W is equal to integral of PdV 1 to 2. Here it is change in volume, sorry, W is equal to integral of 1 to 2 PdV, here pressure and change in volume. Okay, 1 to 2. So here V1 to V2, because there is a change in volume, pressure is constant. But here I will not write V1 to V2, I will write P1 to P2, because pressure is increasing in the boiler. Understood? So instead of PdV, you will write VdP. Here volume of the substance is constant and pressure is changing. If you consider PdV, the equation pressure is constant. This equation is for constant pressure. Constant pressure idu. But here it is for constant, it is for change in pressure. Okay, so integral of Vp1 to P2 VdP. So V is constant, I will take outside, P1 to P2 dP as it is. Now you integrate between P1 to P2. What is the integration of dP? That is P between 1 to 2. So 1 to 2 is nothing but P1 to P2. So V as it is, substitute the upper limit P2 minus P1. So what is the expression for Wp is equals to V into P2 minus P1. Now, so instead of P2 minus P1, I will write H2 minus H1 also. Okay. V into P2 minus P1, then I will write H2 minus H1. So there is an illnotic. So here V into P2 minus P1. Yeah. Okay. So P2 minus P1 volume is constant. So when you are multiplying constant parameter to any variable parameter, V2 P2, this is also V1 P1. V2 V1 both are same. I will take a common, it will become P2 minus P1. So one more equation, H is equal to U plus P into V. Understood? Now H2 is equal to U2 P2 V2. Similarly H1 is equal to U1 plus P1 V1. So in 1 to 2, internal energy is constant. So U2 also constant, U1 also constant. There is no change in the internal energy. So in place of P2 V2, I will write H2. In place of P1 V1, I will write H1. If V is a constant parameter, if your constant parameter is multiplied with a variable parameter, it is V2 P2. Here V2 P2. Again you multiply with constant parameter to the P1 V1 P1. So in place of V2 P2, I will write H2. because H is equal to U plus PV. H is equal to U plus PV. That is, enthalpy is equal to internal energy and product of pressure into specific volume. So that is the reason WP is equal to S2 minus H1 I have written here. So same here, TH, it is also called TH, I told you, right? It is also H or entropy. So H2 minus H1 is a formula for calculating work done on the pump. Understood? So between 1 and 2, which temperature is more? Obviously temperature 2 is more, temperature T1 is less. Understood? So highest enthalpy minus lowest enthalpy will give the value of work done, S2 minus H1, and this is for 1 kg of mass. These are only for 1 kg. If it is for 2 kg, 3 kg, M will be multiplied. So I will write that equation also. So for solving the problems, it will become easy. So I will write WP is equal to M into H2 minus H1. M into S2 minus H1. This is for any mass, and this will be equation for calculating only for unit mass. M is equal to 1 kg. Okay, now once you calculate WP, go to WT, work done on the turbine. So work done on the turbine will be calculated using steady flow energy equation. So WP is over WT, work done by the turbine. Which process it is? 3 to 4 or 1 to 2 or 2 to 3 in the Rankine cycle. Here is a turbine. Here is a turbine. So WT is between 3 to 4 or 4 to 1 or 1 to 2. So between 3 to 4. So it is, I will write here 3 to 4 process, 3 to 4 work done by the turbine. So it is between 3 to 4. So P3, T3 is at point number 3, and P4 not same, obviously not same, P4, T4. P3, T3 will be converted to P4, T4. So P3, T3 is greater than P4 and T4. Okay. Now, so to calculate the work done by the turbine, you have to apply steady flow energy equation, SFEE, that you have studied in last previous subject, basic thermodynamics. Steady flow energy equation anta odi. What is the name of this equation? Steady flow energy equation, that is SFEE. Okay, now apply steady flow energy equation to this turbine. Now first what I do, I will write steady flow energy equation. I will write only steady flow energy equation, then it will become easy for understanding. Once you see the steady flow energy equation, the steady flow energy equation is Q plus M into, P V into U or U plus PV plus V square by 2 plus ZZ is equal to W plus M dot PV plus U plus V square by 2 plus Zz. So this term is inlet, this term is outlet. So for this turbine, which one is the inlet? Which one is the inlet here? So point number 3 is inlet to the turbine. P3 is inlet, T3 is inlet, P4 is outlet from the turbine, T4 is also outlet. So here I will write P3, V3, U3, V3 square, GZ3. What is outlet? P4, V4, U4, V4 square, GZ4. So in the previous semester in the basic thermodynamics we have taken 1, 2. There are only one is inlet, 2 is outlet, but here for our case here it is 3 is inlet, 4 is outlet. So this is the equation, steady full energy equation. Now in the study here in the turbine, in our case, what is the value of Q for the turbine? The value of Q for the turbine here, what is the value of Q for the turbine? It is 0 because it is insulated. Adiabatic process, here I have written adiabatic process, so Q is equal to 0. And one more assumption is the amount of steam going inside the turbine is equal to amount of steam which is coming outside. So M3 is equal to M4, M3 is equal to M4 is equal to 1 kg I will take. What does it mean? Mass of fluid is nothing but steam which is going or supplied to the turbine is equal to the steam which is coming outside the turbine. So M3 is equal to M4. Okay. And here velocity, that is kinetic energy, V3 and V4 both are so same because we are not considering any kinetic energy. I have not written here velocity at point number 3, velocity at point number 4. I have not written anything here. V3 is equal to V4. So only pressure is changing, temperature is changing, remaining everything is constant. So V3 square by 2 is equal to V4 square by 2 is also equal to 1, or difference between these two is 0. Okay. Next, is have taken any potential energy? Oh, this inlet is height from ground level is to there, and P4 T4 is at a height of this one. Is there any potential energy we have considering here? No. So potential energy also not considered here. So ZZ3 is equal to ZZ4. Potential energy is also 0. Here one we can difference is 1, here also 0. But don't substitute M3 and M4 is equal to 0. It will become, entire equation will become 0. It is not that. Mass is not 0. Unit mass of steam is going inside. Now I will simplify this equation. Now substitute all these 4 assumptions in the above equation. So Q is 0, 0, plus M3 is 1, 1. And dear student, what is sum of U3 plus V3 P3? H is equal to U plus P into V. So H3 is equal to U3 plus P3 V3. Correct. Now I will write H3 in place of U3 plus V3 P3. I will write H3 plus V3 square by 2 is 0, 0. Potential energy is also 0. So work done by the turbine is WT. Now W in place of W I will write WT. And what is sum of these two? So H4 again 0, 0. Understood? 1, 2, 3, 4. These 4 assumptions I have substituted in the above equation. So Q is equal to 0. Here Q is equal to 0, 0. M3 is equal to 1, M3 is equal to 1. And sum of internal energy U plus product of pressure into volume is enthalpy. H is equal to U plus PV. We have discussed in the last semester. Okay, H is equal to U plus PV. So I will take point number 3. S3 is equal to U3 plus P3 V3. So H3. Kinetic energy is also 0. Potential energy is also 0. So I need here small mistakes plus WT plus M4 is equal to 1 H4. So I need WT. I need expression for WT. So that WT is equal to, so what is the page number even? This one is page number is 5. This one page number is 5 and this page number we will take 6. So using this equation I need WT is equal to H3 minus H4. Why H3 minus H4 is energy at point number 3 will be more. See the diagram. To the turbine, this energy is more because it is superheated steam. High pressure, high temperature. Energy at point number 3 is more. That is the reason it is first. H3 minus H4. H3 energy minus H4 is nothing but energy at point number 4 is less compared to point number 3. So H3 minus H4. This is for unit mass. If M is equal to 2 kg, 3 kg or whatever be, you will write H3 M dot into H3 minus H4. This is for M is equal to 1 kg. Understood? So this is the expression for WT. Now I will substitute these two, WT minus WP, in this equation. The equation number 1. Dear students, shall I take this is equation number 1? This is equation number 1 and this is page number 3. Page number 3 will be here. Page number 4. Page number 4. Page number 5. This is page number 6. Now in the page number 4, equation number 1, you have calculated expression for WT and you have calculated expression for WP, but QS we don't know. Still you have not written the expression for QS. Now QS is nothing but what? Heat supplied. Heat supplied is which process? In which component? Sorry, in which component? It is in boiler. So between 2 and 3. So between 2 and 3, which point energy is more? Either at point number 2 energy is more or point number 3 energy is more. Yes, obviously at point number 3. So blindly you can write QS is equal to H3 minus H2, highest energy minus lowest energy, but we will write using steady flow energy equation. This is how we have written for turbine. We will write steady flow energy equation tagondo adannu maana. So calculate for heat supplied QS. Heat supplied is in boiler, process 2 to 3. Okay, apply steady flow energy equation. Steady flow energy equation between 2 and 3. So first I will write steady flow energy equation. What is the steady flow energy equation? Q, correct, plus M dot. Now I will take directly H, because instead of taking U, PV, I will take directly H. So H plus V square by 2 plus ZZ is equal to, work, plus M dot H plus V square by 2 plus ZZ. Okay, now for the boiler there are some assumptions. Now look at the boiler diagram. You look at the boiler diagram. Here is the boiler. In the boiler, is any rotational energy, whether boiler is rotating or any components of inside the boiler is rotating? No, there is no mechanical work, there is no rotational energy, there is no torque is created, so nothing is there. So W is equal to 0 directly. Understood? Why W is equal to 0 in the boiler is there is no mechanical energy, mechanical work you are seeing in the boiler, but heat supplied is there. Q is not 0. Again, now this point I will take point number 2 is inlet, point number 3 is outlet. This term is inlet, this term is outlet. So 2, 2, 2, 2. Here is 3, 3 and 3. Here is 3, here is 2. So M2 is equal to M3 is equal to 1. I'll assume that unit mass of steam. Okay. And here again there is no velocity. We are not considering any velocity. V2 square by 2, V3 square by 2 is equal to 0. And we are not considering any potential energy. That is also 0. Okay. So here again I will substitute these 4 assumptions in the above equation. So Q is not 0, I will write Q as it is, but M2 is 1, I will write 1. H2 as it is, write H2. Kinetic energy is 0, potential energy at point number 2 is 0, is equal to W is 0 because boiler is not work producing device. M3 is 1, H3 as it is because heat is supplied, enthalpy cannot be 0, and potential energy is 0, potential energy is 0, here is 0, here is 0, 0 plus 0. So Q, it is QS or QR? QS. So QS is equal to QS plus H2 is equal to, this is H3. So QS is equal to H3 minus H2. Always any heat supplied or work done on the pump, anything, it is highest enthalpy minus lowest enthalpy. That is one hint I can give you. It will be easy for solving the problems. So always highest enthalpy minus lowest enthalpy you have to take. Now QS you have written for QS, you have written the expression for WP, and you have written expression for WT as well. So from equation number 1, I will write using this equation. Okay. So same these notes will be circulated to you in the Google Classroom, okay, or in the YouTube my channel. So from equation number 1, efficiency of Rankine cycle is equal to, what is the expression for WT? Somewhere you have written WT expression here. Now if you take M, that is for any mass, okay, but if you take W2, that is for unit mass. So H3 minus H4. Now I will write directly H3 minus H4. H3 minus H4. If in the equation number 1, minus. So what is the expression for work done on the pump? Where you have written the work done on the pump expression in here in the page number 5. Here work done on the pump, that is M into H2 minus H1. Already you have written, you have derived. So M into H2 minus, but M is equal to, if you take, it is for unit mass. So H2 minus H1 divided by. So what is in equation number 1? What is equation number 1? Heat supplied. Where is the expression for heat supplied? Expression for heat supplied is H3 minus H2. Dear student, this is the expression for efficiency of Rankine cycle. So up to here you have to derive for 10 marks. The procedure looks lengthy because I have delivered you very slowly, so don't be panic. It is very easy to derive in the exam also. So if you practice well, it will become easy for you. Now I will show you the number of pages step by step. And I have asked you some questions, some interview questions. I have asked you, please find answers for those questions. Okay, so in the today class we have to discuss is Rankine cycle. So Rankine cycle consists of 4 major components. So Rankine cycle is a principle on which all vapor power cycles are operate. So if we take steam power plant, which is located in Raichur or Ballari district, a thermal power plant. What is the name again? Thermal power plant. Thermal power plant. So all thermal power plants works on the principle of Rankine cycles. Consist of 4 major components. So pump, boiler, turbine, condenser. So pump, boiler, turbine, procedure I have written. Okay, here. So next page, here, 4th process. And one question I will ask you, and representation of TS diagram for Rankine cycle is here. Efficiency expression. Efficiency is output by input. Output is work here. Work is nothing but net work done, WT minus WP divided by heat supplied. That you have taken equation number 1. Now in the next we have written expression for all these 3 parameters. WP expression we have written. For doubts, you go back to the video and see the procedure, what I have done, what I have presented you. Some steps I have written here. And for calculating work done on the turbine, work done by the turbine, 3 to 4 process. It is 3 to 4 process. Steady flow energy equation, some assumptions, WT expression, heats, and similarly for heat supplied, and final expression for efficiency of the Rankine cycle. And dear students, these notes will be circulated to you in the YouTube channel. Please go through the entire video, and if you have any questions, I will be scheduling in Zoom app online class. So it's my humble request, or if you join there, and you'll have a question answer discussion section. Okay, thank you so much. Bye bye.